right there. Is that okay?
Hi, everybody. Welcome to Wired's first Google Plus Hangout live on air. My name is Adam Mann. I'm the space and physics reporter here at the Wired offices in San Francisco. And today we've got our aerospace reporter, Jason Parr. He's going to be talking to CEO and founder of SpaceX, Elon Musk. So, Jason?
Hi, thanks a bunch, Adam. Sorry for the delay, everybody, and hi, Elon.
Hey.
One of, I guess, the first questions that we had was in talking about some of the delays and the challenges of getting this launch happening. Perhaps you could tell us a little bit about what's been happening the last week, what some of the testing and simulation work that's being done, and getting ready for this launch.
Sure. So, I mean, we've spent a great deal of time testing the hardware and software associated with the rocket and spacecraft, and I could go on for a long time talking about the details of that. But the biggest difference between the last flight, which went quite well, and this one is the docking system. So we have an all-new docking system that's never been tested before, and that's going to go and acquire the space station, sort of lock onto the space station, and then plot an approach vector and maneuver itself over to dock with the space station. And it's a robotic spacecraft that's operating under its own intelligence. It pauses at various points and asks for authority to proceed, but it's really going under its own control for the vast majority of the flight.
That's one of the things that's intrigued me about spaceflight in recent years. You know, we all look back to the Apollo era and even before that, and there was always this romantic notion of a test pilot with a steady hand and nerves of steel commanding a spacecraft. And you know, even the first docking in space was done largely with a test pilot on board. Nowadays, it seems to be about software engineers debugging lines of code. Is that one of the new challenges? Is, you know, that we're sort of taking that human element directly out of it, but there's still I guess the human involvement in creating the software that's allowing this to happen robotically?
Yeah, I mean, exactly. The intelligence has sort of moved to the autopilot system, and in fact, I mean, even in the days of Apollo, they still had quite a bit of computer assistance for that day, you know, for that era. But computers were, you know, vastly more primitive than, you know, today. I mean, your iPhone has more, or Android phone has more computing power than the entire Apollo program, which is kind of hard to imagine. But now that we have so much computing power available to us, it sort of makes sense to make use of it, and you know, and it does alleviate the need to have someone on board the spacecraft maneuvering it into position.
As a software guy yourself, do you think that this drive towards you know, software-driven spacecraft and the automation and everything, does it take any sort of the romanticism out of space travel, that it's not sort of a pilot sitting in a command seat, so to speak? Or is it a fair place to be, since it seems that software people seem to be funding space these days, so why not have software in control?
I don't know. I think software engineers are the fighter pilots of the new generation.
Do you see that?
I mean, come on, you're wired. You should agree with me.
I'm not disagreeing, that's for sure. Do you see that, you know, the fact that there are so many software people getting into it, as far as, you know, people that made the money in the software industry, whether it's yourself, Paul Allen, these types, and then now funding private space endeavors, is that making even more of a push, or was, you know, the obvious natural progression anyways to no longer need a test pilot in left seat?
Yeah, I mean, I think it's certainly a lot safer, and so it's a lot better for you know, loss of life to have it be computer controlled. Well, I should point out, you know, when we do fly astronauts, there will be a manual override capability. So, you know, if something unexpected goes wrong, then it's not in the software to correct it, then it is helpful to have a human in the loop. And so we will have a joystick, and, you know, you will actually be able to control it when there are people on board. But in the initial test phase, I think it's really great that we're able to do it on an automated basis because we're not risking loss of life, and I think that's a great thing. So.
With that risk, after the meeting last week with NASA, you and some of the NASA folks mentioned, put emphasis on the fact that this is a test, that this isn't an actual mission. Is that part of just covering yourself, or is that a real big
mission? It's not an operational mission.
Operational mission, right?
Now we will be delivering half a ton of cargo to the space station and bringing stuff back, but it's going to be it's going to be stuff like food and consumables that is valuable once it reaches the space station, but it doesn't cost all that much if it's lost en route. But it is explicitly kind of in beta mode, so it is in kind of a test phase. So it's not as though we're asserting that success is highly likely. In fact, we're saying that there's a very good chance that the mission does not succeed. That is the nature of a test.
And is that, is it to remind the public out there that this is testing? That I feel like we've become so accustomed to space missions just sort of going up, going down, and the next day it happens again. But we haven't really had that mindset of flight test in space for quite a long time, it seems. Is that part of that goal, is to remind people that's where we're at again?
Yeah, I think it is important to remind people that this is kind of a new rocket and spacecraft. The docking system is being tested for the first time, and whenever you're trying something for the first time, there's a good chance it doesn't work. And so that's why I really want to explicitly remind people that there's a lot that could go wrong on this mission. But if something does go wrong, we'll fix it and we'll be back at it on a subsequent mission. And I think we'll be able to fly at least 1 or 2 times more to the space station this year.
Do you feel that there's more pressure on SpaceX because it's a private enterprise and because there's so much buzz being generated? There's, Gemini 8, the first time that 2 spacecraft docked in space, everything didn't go well and it sort of became a footnote in history. Do you think the same thing, if things don't go perfectly next week, is it possible that it'll just be a footnote and, like you say, there's more missions coming up that you'll be able to engage and fix everything?
Yeah, I mean, I think if something does go wrong, we'll sort it out and we'll be back at it with a subsequent mission probably this summer, and then another flight at the end of the year. So, and I'm highly confident that at least one of those missions will make it all the way to the space station. There should be no doubt whatsoever about our resolve to continue. We will continue, and we'll get it done.
Can you talk a little bit about some of the simulations and maybe some of the failure type work that was done, testing with NASA and that sort of a thing? Are these simulations where NASA throws you a bunch of curveballs and see how the people in Hawthorne react, or is it really a joint work where you test possible failures?
It's a very joint and very, very interactive. I mean, there are really a huge number of tests going on in all sorts of arenas. There are unit tests on subsystems that are going on, and then there are integrated system tests, which we call we call them full hardware-in-the-loop simulations, and that's where we've got all of the electronics, all the avionics, essentially, of the spacecraft out on a bench, and then we feed the sensors information as though it's in space. So it's kind of like a brain in a vat. It actually thinks it's doing the mission, and it's receiving feedback as though it's in space. And we're providing it the physics feedback. So when the thruster fires, we're feeding it what physics would or should deliver. And so it really thinks it went and docked to the space station. And then if something goes wrong, we stop it and we can assess what the issue was and sort it out. And then we also, of course, have to interact with NASA because one of the bits of hardware that's in the loop is the space station. So we do these integrated simulations with NASA, and NASA verifies that we were able to do effectively a virtual docking with the space station. And if there's any issue, then we work together to iron it out.
What have been some of the illuminating things in recent weeks that caused people to some of these delays, like this latest delay? Was it just really some minor details, or was there any kind of a big thing that popped up in these simulations?
No, there wasn't any big thing, and I mean, there's a bunch of minor things that, and to give you a sense of what constitutes a minor thing, these are things that are significantly less than a 1% risk of mission abort. So, because we really care about the mission completing. So nothing we found in the recent months has been related to an actual failure of the spacecraft, in a major way. But it's what's tended to happen is that it's been too sensitive to issues and has aborted when it shouldn't have aborted. So essentially, Dragon got scared and ran away
Right.
when it shouldn't have. And so then we say, okay, well, that means we've been too conservative in the rules for aborting a mission, and we need to go in and alleviate some of those constraints. And we also need to make sure that when Dragon reverts to backup systems, so it's got Dragon's triple redundant, meaning it's got an A, B, and C string. Any one of those three strings can operate the vehicle. So you can actually, like, if you had a gun, you could put a bullet through any two systems on the vehicle, and it could still complete its mission. But we've got to make sure that the logic associated with that works. Does it in fact go to the B string if the A string fails? Does it properly detect a failure? And if you have multiple failures in multiple areas of different types, then does the system still behave as it should?
Cool. And how many simulations has you done with NASA in the last few months, or is it ongoing?
I mean, certainly dozens of simulations with NASA and hundreds within SpaceX.
Okay. Looking at the bigger picture of what SpaceX is trying to accomplish, obviously much of the talk is about reducing the cost of delivering payloads into orbit. Is that what you see as sort of the main goal, reducing that cost of putting a pound into low Earth orbit? Was that the biggest challenge you set out to solve in the beginning, or were these just steps along the way to a bigger end game?
Well, I mean, the reason I started SpaceX was because I think we needed to develop the technology necessary to make life multiplanetary. And with Mars being the only realistic option for creating another planet, essentially creating a base with a self-sustaining civilization. So that's really what SpaceX has been on about for the last 10 years since I started it, is to keep advancing the state-of-the-art of rocket technology. And one of the metrics is how much does it cost to go to space. That's one of the most fundamental metrics. Of course, reliability is also important, and achieving it and being able to create a rocket that's big enough to get to Mars is extremely important. So we've made steady progress in all those arenas, and I'm increasingly confident that if we continue on this trajectory, that we will develop the technology necessary to take people to Mars.
So I want to touch on the Mars thing in a bit, but I guess in the progression to get there, has the work that SpaceX has been doing to reduce those costs to drive the business forward, is it more of a business proposition on how to create a more efficient business, or has there been as much technology to develop and that sort of a thing? Have you seen it more as a company that's had to develop a new business idea or new technologies? Or do they go hand in hand?
No, it's mostly about new technologies. I mean, there's a business element to it as well, of course, because you cannot abstract economics from technology completely, because if the economics don't work, then a large-scale adoption is impossible.
So what can you outline what some of those technologies, when you started SpaceX, did you have something in mind that you said to yourself, well, this is something I definitely have to be able to fix?
Well, I basically said I definitely have to be able to fix rocket technology. We need much better rocket technology. I mean, if you think about it, in '69 we were able to go to the moon, and then with the space shuttle, you could only go to low Earth orbit, and then the space shuttle retired last year. So the United States can't even send people to low Earth orbit now. So I mean, clearly that trajectory is a downward one, and not a good situation at all. So it needs to be reversed, and dramatically so.
But isn't that, I guess the rocket technology is there to do it. It was more of a economic or a political thing. When you say to advance the rocket technology.
You got to separate the economics from any given technology. Yeah. If the economics of a technology are bad, then the technology is bad. That's all there is to it. It is not. There's no such thing as technology that is good abstracting from, completely abstracted from economics.
Good. Do you see the competition down the road for whether it's delivering things to the space station or to low Earth orbit? Is the competition to develop that technology, or do you think the companies like Orbital Sciences or Boeing or United Launch Alliance, are these competitors right now, or do you think that the technology that you'll be developing will take you steps beyond them so that there won't even be a real concern anymore?
Well, honestly, I don't think that there's any I don't think there are any rockets in the world that are seriously competitive with what SpaceX is developing, except potentially what the Chinese are doing long term. But if I think we have the best rocket technology in the world, and it's getting better faster. I mean, our velocity of innovation, I think, is increasing. When we go up and compete on the world market against the Russians, Europeans, Chinese, or domestically Boeing and Lockheed, with the sole exception of Defense Department business, where they have a sole source contract that I think is completely outrageous, except where Boeing and Lockheed are protected by egregious contracts, SpaceX wins the competition.
I'm curious, as chief designer for SpaceX, I assume you've enjoyed learning a lot about rocket design and space vehicles and orbital mechanics and this sort of a thing. Is there something that sort of stands out in your education of the past decade or 15 years in the space industry that's really stuck out as something that you've enjoyed more than and was sort of a surprise? Or is it the whole package?
Those are two different things. I think I've certainly enjoyed. I mean, it's really fun to see a rocket launch. That's really epic, and even to see rocket engines tested on the ground and huge structures created. I mean, just the epic nature of it, and just how big and powerful things are. It's like, wow, you just don't see that in everyday life. So that's really cool. As far as surprise. Well, I mean, I've probably been surprised by a lot of things because I didn't really know anything about rockets, or not much about rockets before starting SpaceX. But I wouldn't say there's any huge surprises. Just maybe a lot of small and medium ones.
When you said you didn't know a whole lot about rockets before starting SpaceX, when did you get this idea? Were you a kid who played with model rockets, or was this idea that you wanted to go to space and make life multiplanetary, is that something you got later in life? Was that something you thought about as younger, or?
Yeah, well, I did actually. I mean, I did build rockets when I was a kid in South Africa. I mean, in South Africa we didn't have ST's rockets. So I had to actually mix my own rocket propellant grain and everything. You
did know something about rockets earlier then.
Yeah. I mean, so it's not that hard to make a solid rocket. Although, I mean, the hardest thing was getting the saltpeter, which you had to come up with some excuse to get it from a chemist because you couldn't just buy it. But the reason for SpaceX is because I think when I was in college, I thought, well, what are the things that are most going to affect the future of humanity? What are the important problems? What are the most important problems that need to be solved, in my opinion, and that where one could apply technology to solve them. And the three things that I came up with were the internet, sustainable energy, and space exploration, particularly making life multiplanetary. In terms of the internet, obviously it's like it's like humanity acquiring a collective nervous system Whereas previously we were more like a hydra, like a collection of cells that communicated by diffusion. With the advent of the internet, it was like we suddenly got a nervous system. In terms of the human collective, it's a hugely impactful thing. And then sustainable energy, I think, is the single biggest problem of the 21st century. We either solve that or we're screwed. Obviously, it's tautological. And then making life multiplanetary is, I think, important because for the last 4 billion years, life has been confined to Earth, life as we know it, at least. I think there's some chance that something terrible will happen on Earth and the light of consciousness is extinguished, and I think we should apply some of our resources to prevent that from occurring. I'm not saying it should be a huge number, but perhaps 0.25% of the GDP or something like that. And in order for that to occur, we need the technology developed to make that possible. So what we're doing at SpaceX is trying to help make progress in that direction.
With the trip to Mars, where do you see the biggest challenges right now? Do you think the technology exists right now obviously we've put robots on Mars. Is it that the ability to get a human there to make the trip, to sustain life there? Where is the biggest roadblock to getting a person on Mars right now?
Well, the biggest, we don't, there's not currently a rocket big enough to take people to Mars. But even if there was, the issue is not one of having some super expensive program that is able to do a flags and footprints mission to Mars like we did with the Moon. That would set a new high altitude record and would be interesting, but would not be all that impactful on the future of humanity. I think what really matters is developing a system that's capable of transporting huge numbers of people and cargo to Mars, such that it can become a self-sustaining civilization. And getting the cost of a trip to Mars, of moving to Mars, I think, down to something that kind of a middle-class person in America can afford. If we can do that, then I think it will occur. It will be a sort of a naturally self-sustaining reaction, and life will become multiplanetary. Just as in the early days of the United States, that's really kind of how the United States was formed. The cost of a trip to America got down to something that a relatively middle-class person in say England could afford, and so enough people chose to make that journey to form the beginnings of the United States.
With some of the new companies that keep springing up, just this week we had Planetary Resources announce their plans. Do you see all these coming together as part of that, the fabric that's needed to create a trip to Mars that can be affordable? Do you think asteroid mining is going to be a key part, for instance, to get that ability to open up space travel at a longer distance?
I think asteroid mining is something that, frankly, is only relevant in the context of a serious effort to settle Mars. I don't think it's relevant in an Earth context.
So all these companies that are springing up, whether it's SpaceX or Planetary Resources or some of these others,
SpaceX is quite different from Planetary Resources.
No, I realize that, but do you see that all these companies are sort of all putting pieces into the puzzle that will allow this trip to Mars, that will allow multiplanetary life? Or do you see that SpaceX is taking its own direct path and you'll pretty much be able to do it on your own?
I think we'll be able to do it on our own. Or at least, I want to make sure that we can do it on our own. It's not as though we necessarily want to, but if we have to, I think if that's the path that is required, then we must be able to execute that path. And like I said, I think mining asteroids it's not necessary for creating a self-sustaining civilization on Mars, but it could potentially be helpful, as a refueling thing. But it's not required.
Do you see the first trips to Mars being one way or a round trip?
I think round trip. Yeah, I think it's the one-way thing. I think is unnecessary because see, in order to I mean, like I said, the thing that's important is that we're able to transport ultimately millions of people, millions of tons of cargo to Mars. And in order to do that, in order to be able to make that feasible, you really need the spacecraft to come back. So whether the people choose to come back or not is beside the point. You need the spaceship to come back. So it's just like in the early days of in the early days, you need reusable spacecraft that return. When England was establishing colonies in America, like they needed the ships to return. If the ships were just one way, I mean, they'd run out of wood in England.
So does that challenge then again bring home this idea that we need a new rocket needs to be developed, spacecraft, all
yes.
that?
Yeah, we definitely need to develop a new generation of rockets. So I don't, for example, think that we'll be sending people to Mars using our Falcon line of rockets. I think it'll be with the next generation of rockets beyond that. But Falcon will be helpful as a technological stepping stone.
Are some of those ideas being put to paper or put to the CAD system yet?
Yes, I believe I have a design that will close.
And when do you think there'll be any kind of information being put out by SpaceX that explains some of its Mars projects? Is that something that's going to happen in a few years, in a decade?
Yeah, I mean, I think we'll probably talk about it maybe at the end of the year or maybe sometime next year.
Oh,
we'll have to see. Yeah, I think right now we need to focus on docking with the space station, and not get distracted from that important task. But I think probably talk about it in a year or so. Well,
great. Well, Elon, I really appreciate the time, and good luck with the docking mission set to go off next week. And we look forward to hearing about Mars in the future.
All right, sounds good. Thanks. Good speaking with you.
Thank you.
All right.
Thanks, guys.